Welcome to The Explainer. Today, we're pulling back the curtain on the Internet's invisible engine room. We're going to talk about the magic that happens in that split second after you hit enter and how a system that works like a global phone book connects you to, well, anywhere you want to go online.
Think about it. It's an action you probably do hundreds of times a day without even thinking. You type a web address, hit enter, and bam, the page is there. But what's really going on in that half second? That nearly instant result actually hides an incredible, high-speed journey that crisscrosses the entire globe.
So here's the fundamental problem, right? We, as humans, we remember names like Google.com, but computers, they speak in numbers, long strings of numbers called IP addresses. Just imagine if you had to memorize a unique phone number for every single website you visit. It'd be completely impossible. That's the challenge that had to be solved.
And the solution is this beautifully elegant system called the Domain Name System, or DNS. Its job sounds simple, but it is absolutely essential. It's the Internet phone book. It translates the names we can remember into the IP addresses computers need. Honestly, without DNS, the web as we know it just wouldn't work, period.
Okay, so let's actually follow one of these requests on its journey to get an IP address. This whole process is called a DNS lookup. And, it's really a masterclass in how to build a fast, efficient, worldwide network.
So, before your request even leaves your computer, it does the smart thing. It checks if it already knows the answer. It has a quick look in its local caches, first in your browser, then in the operating system itself, and hey, even your router might have a copy stashed away. If you've been to the site recently, the IP address is right there, and the journey is over before it even began.
But what if it's a new site? Well, then your request gets sent out into the wild. It has to navigate this huge, hierarchical system that kind of looks like an upside-down tree. And this structure is the secret to its speed. At the very top, you've got the root servers. Now, they don't know every address, but they know exactly who to ask next. They point the request down to the next level, the top-level domains, or TLDs. This is where you find the servers for whole categories, like everything ending in .com or .org. From there, it gets narrowed down again until it finds the one specific address it's looking for.
So your little request goes on this multi-step quest. It starts by asking a special server called a DNS resolver, which is usually run by your internet service provider. Think of the resolver as a super helpful librarian. It doesn't know the answer itself, but it knows exactly where to find it. It's going to ask the root server, then the TLD server, and finally, the authoritative name server.
And this is a great illustration of that path. Your request goes to the DNS resolver. The resolver asks a root server, hey, where do I find the .com domains? The root server points it to the correct top-level domain server. Then the resolver asks that TLD server, okay, great, now where's the server for the specific website I want? And finally, that TLD server points to the last stop, the authoritative name server, which holds the golden ticket, the actual IP address, and sends that answer all the way back.
Now, let's talk about those root servers at the very top of the hierarchy. They're the starting point for everything, and there's a really common and pretty persistent myth about them that we really need to clear up. You've probably heard this one before, that the entire stability of the internet rests on the shoulders of just 13 physical servers. 13 machines scattered across the globe. It's a really fascinating idea, but it's not quite the truth.
Now, the myth isn't just pulled out of thin air. It actually comes from a real technical limitation way back in the early days of the internet. The original system was only designed to handle 13 IP addresses for this critical root zone. But in reality, there are over 600 physical root servers spread across every populated continent. How is that possible? Well, it's thanks to a really clever networking trick called Anycast routing. It basically lets hundreds of different servers share the same IP address. So when your request goes to one of those 13 addresses, it's automatically sent to the physical server that's closest to you. Pretty smart, huh?
And this massive, redundant system is absolutely crucial for keeping the internet running smoothly. There's probably no better example of this than the totally chaotic worldwide launch of the mobile game Pokémon Go back in 2016.
I mean, this game was a runaway hit. It was way more popular than anyone at the company, or even at Google, could have possibly imagined. They had planned for 5 times their most optimistic traffic estimate, but the actual traffic on launch day, it surged to 50 times that estimate. 50.
So as the servers buckled under that insane 50x load, they started to fail. And the game's app, trying to be helpful, would immediately try to connect again, But when millions of phones are retrying at the exact same moment, you get these enormous, synchronized traffic spikes. It's called a thundering herd problem, and it pushed the load to catastrophic levels.
This created a classic cascading failure. It's like dominoes falling. One overloaded system brings down the next, which brings down the next. Engineers were scrambling, working to isolate the game's traffic to protect the rest of the internet, and they had to implement limits to try and contain the overwhelming demand from all the phones.
You know, this massive outage ended up teaching the entire tech industry some incredibly valuable lessons. The biggest one? You have to stop all the clients from retrying at once by building in random delays, or jitter. It was also a stark reminder of just how quickly one small failure can cascade into a global meltdown.
So this entire complex system of resolvers and servers, it's not just some abstract technical thing. It has a real direct impact on your internet experience every single day. And here's the part you might not realize. You actually have a choice in which phone book your computer uses.
By default, you're using the DNS resolver from your internet service provider, and that's usually fine. But you can easily switch to a public DNS service, like Cloudflare's 1.1.1.1 or Google's 8.8.8.8. And these public services can often be faster, they can offer much better privacy because your ISP can't see every site you look up, and some even come with extra features like ad blocking or security filters.
So from a simple keystroke to a cascading global failure, the domain name system really is the unsung hero of the internet. It's this distributed, resilient, and incredibly fast system that makes our digital lives possible. Every single click you make triggers this lightning-fast journey across the globe. The only question left is, now that you know the journey, will you think differently about the phone book you choose to use?